So last week we went through all PySpark related read API transformations and actions. Actions means write API and displaying the data. So this week what we will do, we'll focus on Delta and then advanced concepts. Okay, so today we'll just start with the Delta. What is Delta? Why Delta? And Delta Lake features. Okay. So what is Delta? Delta is it's not a storage. So most of the people will have a little confusion about a data lake and Delta Lake. Data lake means a storage. The data lake means it depends on cloud. Like if you are in GCP, then GCS, Google Cloud Storage is data lake. If you are in on-premises, HDFS, Hadoop, Distributed File System is on data lake. If you are in Azure, Azure data lake is an data lake. If you are in AWS, S3 is a data lake. If you are in IBM buckets, or can say IBM storage and Oracle storage. So these all are data lakes. These all are data lakes. Data lakes means a distributed file system where it can store the data. So when it comes to Fabric, or one lake is a data lake. Because one lake is on top of data lake, they are giving directly a storage service managed by them. Okay. Instead of you are going to create a data lake, they are creating internally and they are managing as a one lake. Okay. So your one lake is a data lake here. And what is Delta Lake? Delta Lake is not a storage, just a PySpark API. PySpark API. So what this will do? It will enable you database features on top of file system. So why we need a Delta? Why we need a Delta? Then what are the major features it is going to provide? If Delta is not available, we have to use databases. But if you use the databases, then you won't get a data lake features. But if you use a data lake is having some disadvantages. So what are the major disadvantages of data lake? First, we'll understand that. So the challenges in the implementation of data lakes. Data lake means file system, where you can have a files. That may be any type of file, any size of file. But those files are missing with ACID properties, which same file cannot open by multiple people at a time. And same file, you can't update the data, you can't delete the data. Files will have only two concepts, override the file or append the data. Only the two concepts. But you can't update data, you can't delete data. Same time, you can't open a file with multiple people. That's called ACID properties. ACID properties are missing on data lake. Atomicity, consistency. So when it comes to consistency, at the same time, multiple people cannot read data, cannot write data in the file system. That's a disadvantage of data lake. Durability. There's no guarantee when once you append the data, it will be available for all, because it won't manage the transactions. Files, it won't manage the transactions. Then other features, when you look at the schema enforcement, like database will have this metadata management. Data does not have a metadata management. Data lake cannot manage the columns, data types, because just it's managed as a files and folders only. So there's no metadata management, like managing databases, catalogs, tables, columns, data types. That is not possible on the data lake. Lack of consistency. Yeah, that's a major disadvantage of file system. So if someone open the file, if you try to open the file, you can't open the file. You will get an error. Okay. So lack of data quality. If you cannot able to manage the transactions, if you are blindly appending the data or overwriting the file, there's no guarantee on that data quality, because it can't validate a data types. It can't validate a data internally. So it can allow duplicates, it can allow nulls, it can allow bad data or other data types data. So when you look at data lake, another disadvantage is lack of data quality. Then too many small files. Even if you have more number of files, it will take more time to read from disk. That's called disk IO. Disk IO. Consider if you have a 1 GB data, one file is different. Same 1 GB data, 1000 files is different. Maybe each file size 1 MB or maybe less than 1 MB. But if you're reading one file is different, reading 1000 files is different. So 1000 files, first you need to read from disk, means you need to open the file, disk IO, then you need to read the data, then close the file. So opening file and closing file will take more time than reading data. So if you have more number of small files, then it can degrade the performance. Even whenever you're trying to create a data file, in between, if something happens, if any network issues or any other issues, job files, then it will have a corrupted file. Okay, files will have a corrupted file. The corrupted file, it won't delete automatically. You have to identify and delete manually. Means, but if you have a proper transaction management, then you can go and manage those. Files. If transaction is not success, go and delete file automatically. Manually, you don't need to delete. So every data lake, you look at the data lake, a data lake is missing these features. But every database will have these features. But if you go with the database, what will happen? Databases cannot store all types of data. Your databases are purely structured. The databases supports only query language, limitations on the programming language, limitations on the types of the data. So we are looking for a data lake, but on top of that, we are looking for all these features, which we need to fix all these issues. Okay, means technically we are expecting all these features. So Delta is going to provide you all the features, which is going to provide ACID transaction on top of the data lake, scalable metadata, where it will manage all the metadata, means columns and data types. Time travel, you can go and query a previous transaction data. You can go and query previous. Whenever you update or delete, the previous history will be there. Anyway, it's an open source. The databases are not open source, but Delta is an open source, so anyone can go and use that. Both the batch and streaming. So real-time data processing or batch processing, both it will support. And metadata validation also can be done. It's called schema enforcement and evaluation. And it will have audit history. Means who is inserted, who is deleted, who is updated, that audit history. And it will support DML operations where you can do insert, update, delete. Where you can do insert, update, delete. But how to use this Delta? Just you don't need to do anything. Just whenever we are writing a table or creating a table or file, you need to just change the format. Backend, it is going to create every table is going to create a table with one folder. That folder name is _ Delta log. Inside that folder, it will have a JSON files, sequence JSON files. Inside that, whenever you insert the data, whenever we update the data, the backend, it will have a JSON. But data files always it will store in a Parquet files. But data files is going to store in a Parquet files. Parquet is one of the open source format, best suitable format for Spark. Whenever we create any table, every table, it will have a table name as a folder name. Inside that, it will have a data files or Parquet files. And every table, it will have a folder called _ Delta log. Every table, where it will keep all the transaction log as a JSON files. JSON. So let's verify that. So we already created a multiple tables. So go to the workspace. We can go to landing. So we already created a table. So these are our Delta tables. So let's understand each Delta table. Like even if you go and query this, okay, even if you go and view this files, You see here, every table is having underscore delta log folder and the data in Parquet files. If you go to inside this folder, you can find the JSON files. So whenever you do insert, update, delete, every time it will have the transaction log. So JSON file also you can see here. Even if you go to another table, we can see the data, but the backend, when you go and verify the data files, the data file will be a Parquet file, and every table it will have underscore delta log. Then you can find this JSON files. And it will have another inside commits folder, like internally it's manages that when you are doing a insert, update, delete, internally it's managed inside that, then finally it will have a JSON files here. Okay. So every table, like if you go to every delta table, say this. The delta table is combination of two things here. One is the data in a version Parquet files. Another one is transaction log, which will be there in a JSON. Will be there in a JSON. And inside the JSON file, it will have a statistics also. Inside JSON file, it will have a statistics also. The same delta table, if you go for a Databricks, you'll have another file called CRC file. That is managed by Databricks. But here you don't see CRC file, only a Parquet file and JSON files, we can see this. So let's verify one table, then we'll understand this. We already created an employee table with a partition, even without partition. Let me create a new notebook. So inside the tables, you will have a folder name as a table name, like your table name as a folder, where you can find this data file. And inside that, it will have another folder called underscore delta, like a subfolder. There you can find the JSON files. See here. Consider if you go and read this JSON file. This is version, initial version. You see the commit info. Commit info means when the table is created, when it is created, timestamp, and the create table. Whenever we use a PySpark, so backend it will have a create table as select from particular data frame. Then if you have a partition column, clustered by column, that information which you can see here. Then how many files it is created, how many rows it is created, the size of that, and other tags also you can find here. Means the version, Spark version, Delta version, okay, and the transaction ID. Hash here. Then metadata also, which you can. Metadata means all the columns and data types information. And then transaction protocol. Transaction protocol means reader version and the writer version, which it will understand who is reading the data. So they will read a version 1. Who are going to write, they'll write in version 2. Okay. That's called transaction protocol. Readers will have their own snapshot, writers will have own snapshot. And how many files it is added, that file name, you say this is the file name it is added. In that file, size of the file, when it is modified, the number of rows statistics. The statistics is nothing but number of rows, each column, minimum value, maximum value, null record count. So this is called statistics. So every table of data will be there. Data will be there in a version Parquet files. Transaction log and statistics will be there. Where it will be there in the JSON files. Statistics, transaction log. What is transaction log? Commit info. The commit info is a transaction log. who is created, when it is created, but here the timestamp which you can see here, the metadata, transaction protocol, and the statistics. Go and verify another version. Now this is another version. So whenever you do any insert means only one file will be there, add file. Whenever you go for update will be there for two files. One is for add, one is for remove. Whenever you go for the delete also you will have two files. One will have a add, another one is for a delete. So this. So old file, it will treat as delete and then it will create a new file. So whenever we go for update and delete, you can find this add and remove. Add means new file will be created with the new data. The old file will have that it will logical remove. Whenever you say it's remove, physically it won't remove, the file will be available. But that will when you are querying the data, this file will ignore. Only whenever this add file is there, that file only it will read. That's a transaction log. So why is a partition table also? We created a partition table as well. The tables. Table name is there underscore delta underscore log. So here you can see the JSON file. See the commit info, metadata, transaction protocol. Then how many files it added, that each file you see here statistics. This is one file, partition value is 30. This is another file, partition value is 20. This is another file, partition value 10. This is another file, partition value 8. You can see the partition value means it is a partition table. That's why you see here partition column. Okay. Now, similarly, we'll go and verify another table. Tables. So we have a JSON files, JSON version 1, version 0 is initial one, version 1 is the latest one. Maybe after that, if you do any changes, we go to the initial version. So this is table commit info and the cluster by column. Two columns we created last week. Okay. Department number, salary, clustered by, not partition by. So you don't see subfolders. So only one data file which we can see. That you can see the clustering columns and the domain metadata. Write features is clustering, transaction protocol, and metadata. If we go to the version 1, this is again a commit info. It's a overwrite. Okay, looks like it is without cluster by. We did, I think, overwrite. You see this? Write is there. So partition by, no cluster by. Okay. Looks like we did a overwrite. So every table it will have transaction log that you can verify in a JSON or you can verify in a SQL query. The one query is describe history and table name. Describe history, table name. Then it will give you information about the table. Just 1 minute again. Two transactions are happened. One is create table, then write, overwrite. We did a overwrite. Then another table also will go and verify here, which is EMPN underscore data. Okay. There we did more transactions, like 0 to 7. You can see this. Multiple times we created a table. Okay. We did append, we did overwrite. The time reader version, the writer version, which you see, it changed. And every time, whenever we do the statistics, which you can see, number of rows it is created. If you go and query this table, see number of records. So if you want to delete data, I'll do what I'll do where commission is null. So I want to delete this 10 records. Now you'll have another. Now I deleted 10 records. Now go and verify here. See, another delete transaction is happened. Okay. And the reader version is 7. The reader version, you see, reader version is changed. Whoever is reading, they'll read only 7. The 7 means at that time, whenever we are doing that. And the writer version is 8. So we created a newer version. Now, if I want to restore, even we can go under restore. Even if you want to restore, we can go under restore that previous version. So timestamp version. This is called edit history. So which you can find the edit history. So whenever we do update, whenever we do delete, every transaction it will have a new file. Every transaction it will have a file, data file, Parquet files. Okay. And that transaction related metadata will be available in that JSON files. Transaction log. So whenever you query, the transaction log will have which file is the latest one. That file it will read. The old file it won't read. So let's go and verify that. Let's go and verify this. Whenever we do delete, right, what will happen? Update. It will create a new file. Then the old file it will treat as remove. But physically it won't remove. It will treat as remove. It will be available. But whenever you read based on this log, it will read this file. It won't read the old files. This log will have old files. This log will have a new files. Let's verify that. We did a delete. Tables. Table name underscore delta log. Now you see this is the latest version. If you go and verify here, one file is added, one file is removed. But this won't be removed physically. This file will be there. when you will get this file, this is an older version. So whenever you are reading, now whenever you go and read the table, you will get the latest version. This is the added file. So you can go and query that. You see here, only the main data is there. 10 records we already deleted. If you are looking for old data, deleted data, the deleted data is available in this file. Okay. So now what we need to do? We need to use version as of 7. You see, deleted data also is there. Actually, we deleted this commission null. You see here. So this is about delta. Delta is going to keep the transaction log. Whenever we do update and whenever we do delete, it will have two files, one for delete, one for add. Delete means physically it won't be deleted. It will delete after 30 days. Okay. But physically it will be deleted after 30 days. You see number of files removed, number of bytes, number of rows copied in the new file, 5 rows. The new file will have only 5 rows. Now you can see here the number of records 5. So if we go on latest version, only 5 rows which we can see here. If you want to restore, you can go and restore. Restore table, table name, version as of 7. 8 is the latest version. Okay. Restore table, table name to this version. Now, whenever we query, we see 5 records, right? Now we are restoring the previous version. After restoring, if you go and query this table, you can see the 15 records because the deleted records, now you see, restored it. The file is restored. Now, if you go and verify here, time travel, go and get the previous data, restore the previous version data. Now you see 15 records. Now we are able to get the deleted data. Earlier we deleted, now we got that. It's called time travel. Time travel means you can access earlier versions. You can go and verify this version number or timestamp basis, or you can go and get that, restore that. If you go and verify describe history, you can find that again that audit log. This is audit log. What we did, restore, which version we did, that information also we can see. Version 7 we restored. Then version latest version is version 9. Okay. How many files it is restored? So time travel. Time travel means you can go and get previous version data, or you can go and restore that previous version data. And audit history, which is going to keep all the changes, logs history. Okay. It will support DML operations. So we are able to achieve DML operations. Now we inserted data, we update, like we deleted data, even we can do update, even we can do merge as well. It's an open source. It's an open source. So we can go and create a partition table. We can go and create a partition table. Anyway, Delta supports a partition table, like we created a partition table. That may be any column, maybe a number of columns, like year and month. Or we can go and create a cluster by also. Liquid clustering, we call it as liquid clustering. Liquid clustering major concept is nearby data, it will store in one place. Nearby data, it will store in one place. So nearby data, it will store in one place means when it is creating a files, it will store the data, nearby data in one place instead of keeping that data in another file. Okay, let's look at this. Before clustering, like you have a file 1, file 2, file 3, file 4. Okay, if you look at the data, okay, if you are creating a partition by date and type, okay, partition by date and type, these two columns. If you look at this, you see November 2nd, file 1 also having November 2nd, file 2 also is having November 2nd and November 3rd. You see this. File 3 also is having November 2nd, November 3rd, and November 4th also. But if you do the clustering on this two columns, even you see the values here. 2, 3, 4 also is there. 1, 2, 3, 4, 5 also is there. But when you do this, first priority is date column because the cluster by date column. What will happen? You see here, this values, whatever these values, will be nearby in data in one file. So this is not a nearby. So this is same values. It will shift here. This will shift here. That's why you see here. 3 also is properly shifted. Then 4 and 5. November 4th and November 5th. Okay. The date. You see here now. 3rd also here. 3rd also here. 3rd also here. 2nd is available here. 2nd is available. 2nd is available. So it is not nearby. So whenever you do cluster by nearby data in one file, nearby data in one file means now November 2nd here, nearby data, November 3rd here, November 4th and November 5th. Similarly, here also you see inside that again. Inside that, if you have multiple values, November 2nd, then you see here only 2nd here, and then 3rd and 4th. Inside 3rd, then whatever the values are available. Inside 4th and 5th, whatever the values. It's called nearby data in one place. Nearby data, one place. It's called cluster by. So we created a cluster by, we created partitioning. Partitioning can be done only while creating a table. Clustering can be done alter a table or while creating a table, but clustering only supports a SQL, not PySpark. But when you are doing a partitioning, even you can use a even you can use in PySpark as well. So in the write API, you can go and specify the partition by while writing into a table. Like earlier we did that, the last session we did. But clustering can be done through SQL, but partitioning can be done through PySpark or through SQL. Okay. So those are major features when it comes to Delta Lake. Those are major features when it comes to Delta Lake. So Delta Lake is not a separate storage. Your backend data will be storing on Data Lake only. On top of Data Lake, this is an API. API means while we are writing, just will specify the format as Delta. That may be a save as file. That may be a save as table. So, but Delta, when it is specified, whenever you specify the Delta, it will create a Delta table, that icon also, which you can see here. This is Delta table. Okay. So read API also, while reading, you can use directly read table or read by path. If you are saving as a table, it will be there in the tables. To save a files, you can go and save the files inside a files location. It's called save option. So inside files, you can go and save this, or inside tables, you can go and save this as a save as table. That's a save option and save as table option. So write API, the read API. Read API means you can read by table or you can read by path. Read by table, directly read by table, or read by path means you can specify the path, then format. If it is a table directly, we can read by table. Like we can see this read by table. even if it is in SQL or even if it is in a PySpark. PySpark also you can read the same table. You'll have multiple options. You can create a data frame. You can use Spark dot read dot format if you have a file, but if you use a Spark dot table, then reading by table. If you have a file, then Spark dot read dot format. Similarly, you can use another option is Spark dot SQL. Here you need to use a SQL query. Instead of table name, you need to use a query name. If it is read by path, we created a delta table we created in this location. In the output, here we created a delta table. Okay. Output under the files under output, there we created. Then we need to use Spark dot read dot format delta and load files output. This is delta table. Like similarly, if you want to read other formats, then the format ORC file, like we created a ORC. Okay, the format. While reading by file particular location, okay, path. So you can read delta by path. You can specify the path. Even you can read the same by path in SQL also. How to read in a SQL? Select a star from. Instead of table name, delta dot, then open and close with. Open and close with. It's not a single quote. It is acute ascent symbol. You can read by path in SQL also. This is read by path. Okay. Similarly, you can read by metastore. Just a table name is called read by metastore. The metastore object name. So in this table will be there in the metastore. It's called object name. So that we don't have the table. If you have a table, that table name, like here, this is a table, emp underscore data. That is. This is read by metastore. This is read by path. This is acute ascent symbol, which you can find this about tab symbol. It's not a single quote. When you are reading the read by path, use this. Open and close with the path should be open and close with. Only that time we need to use acute ascent. You can go to so here you can find this. Above the tab, you can find this. Single quote, double quote will be available here. This is acute ascent. So remember, depends on the your keyboard manufacturer. A small difference will be there, but above the tab, which you can find this. So tab above the tab. Single quote, double quote will be available here. This is ascent. So whenever we are writing ascent characters, like A, then ascent, B, ascent. So that time we'll use this character. Similarly, when using a path, this is not a single quote. So if you specify single quote, you will get error. Single quote, you can other while not reading, while creating a table, path normally will specify single quote, double quote, but not while read by path. Okay, you will get this error. Only while reading, you need to specify this %, okay? Only while reading. So format type, if it is delta table, delta dot. Instead we have other formats. I want to read a CSV table or Avro table. So then you want to read a JSON, that JSON folder location. It's called read by path. Similarly, if you want to read a CSV file, that folder where CSV files are available. Okay. Similarly, if you want to read a ORC file, so this is file type dot path. In SQL also you can read by path. This is read by table name, or you can say metastore, because the table will be available in metastore. We can read by metastore. So that's called read by path, read by metastore name. Okay. So I created a separate notebook for this Delta Lake, whatever we covered the features, right? I created a separate notebook. I'll share that notebook. I'll upload in the drive. Like you can go and import. Like in JSON, the last session we covered the JSON, right? The JSON, I already uploaded that. The JSON file already uploaded. So tomorrow we'll understand this delta features, delta merge and cloning. Today, whatever we covered, I created a separate notebook. All the features, okay, Delta Lake features, whatever we covered, you can find a separate notebook of the features. So creating a data frame, then creating a table. So you can save option, save as table, partition table, partition by path, partition by table. Okay. You can go and save this in a specific location. Go and save this partition table. So that's called save as data. Describe history. It will give you the audit log. Describe details. It will give you the table name and the location and the columns. Not the columns and data types, partition column or cluster column. Extended will give you that columns, data types. Extended will give you columns, data types, the table type and other things here like this. Describe detail will give you which catalog it is storing, means which it's lakehouse, and then where which physical location where it is storing, when it is created, any partition column, number of files, size of the table. Okay, that information you will get. Then commit info. So whenever you go for JSON file, you can find all this information. The commit info, metadata, whenever you insert, it will have add file. Whenever you do update or delete, it will have a add file and remove file. Protocol for readers and writers to support ASCII semantics. Okay, friends. Same time, other people can read the data. Some other people can go and delete the data or update the data. That's a transaction protocol. Like databases manages that. Similarly, here also it manages that. We went through all these JSON files. I've already explained this commit info, transaction protocol, metadata, add file, remove file. Okay. This called understanding delta logs. Commit info, metadata, add file, remove file. Then what is schema enforcement and schema evolution? Okay. Let's understand these two features. Okay. So let me assign that. Remove that old lakehouse. Assign the lakehouse. We need this data file. We need this data file. The data file not available. You can go and upload. I think let's go verify that employee data file. We have employee data file here directly. Here we have. You can specify the particular path. So we'll understand schema enforcement and schema evolution. That feature. Like we went through all these features. Time travel, edit history, DML operations, right? Let's understand schema enforcement and evolution. Okay. Let's understand schema enforcement and evolution. Then today we can complete this. Tomorrow we'll understand the cloning part. Then merge. What is merge? How to use merge. You see, these are the columns and the data types. These are the columns and data types. Okay, if any changes are there, you can see you have an existing table, then on top of that, any changes are there. So first what I'll do, we are going for us save in this location and save as table. Save as table, let's verify. Are we have already existing tables. Delta part, like tables are not there. Let's go and create a by path, by metastar. Both EMP delta and this EMP delta by path, then EMP delta part partition table in a particular location. Both tables you can read by path, you can read by metastar. Partition table, non-partition table. Okay, just now. So what is schema enforcement? What is schema enforcement? So let's add one column top of that. Let's add. I'm going to add two columns on the data frame. These two columns is now. This is created date and created by. Okay, just added. So current date and a lit using a lit function added some static value. Okay, literal value. Now the table does not have these two columns. If you go and try to insert the data into that table, like append or right. What will happen? It will raise exception. Why? Because your table does not have those two columns. This is your table schema. But data frame is having additionally those two columns, these two columns. It will raise exception saying that the schema mismatch is detected while writing into delta table. So if you want to, this is called schema enforcement. What is enforcement? What is enforcement? Prevent the users from accidentally pulling their tables with a mistake or garbage data. By mistake, if you are trying to load a wrong data frame into wrong table, okay, then if that data frame columns table columns are not matching, that's why it is treating as both are not matching. So that's why it is raising exception. That's called schema enforcement. Enforcement means if the columns are not matching, then it will raise exception. Inconsistency. Okay, columns inconsistency. Then what is evolution? Evolution means you want to add those columns in the target table. That's called add a new columns on the data when if it is required. Those two columns I want to add that. So this is called enforcement. By default, it will raise exception. Still, if you want to load the data, then you can go and use, there's an option called merge schema true. Merge schema true works only for the new columns, not for data types. Remember, this will works only for new columns, not for data types. Now the merge schema is working. If any changes in the data types, then merge schema won't work. This will work only for the adding a new columns. So I mentioned here, add new columns on data when if it is required. Now it is executed. Let's go and verify. It will have a new columns in the table. You see two columns has been created in the table. The data also is available. Let's verify. Let's try to change the data type. If we change the data type, what will happen? It won't allow merge schema. Merge schema only for adding a new columns. Let me show you that. From PySpark.sql.functions. Import data frame with column. I'll use hide date. Hide date actually a string. Now I'll change to date using a toDate function. dd y. Now you see the data type is changed now. Okay, let's try to do that again with the merge schema. We'll raise exception. Hide it. Merge schema won't allow data type changes, only adding a new column to allow. But how to achieve that adding a new column? Okay, then override schema. But override schema it won't allow with append. You have to do the override. Okay, override schema for any data type changes. But we have to delete old data. Then only override schema works with override mode, not for mode. What override will do? When you use append, override schema will work, but problem with it is existing data. Override schema, then the new table will have a new data type, new columns. Let's go and verify now. This is old data type, you see, string data type, hide date, right? Let's verify query now table. Now the hide date is changed now date, proper date. So this is the difference. Schema evolution. Schema evolution, one is merge schema works for the new columns, but you don't need to, there's no impact on existing data. Your old data will be there, use append mode. But if you want to change any data type, then you have to use the override schema. If you are using override schema, you have to use override. Then override will delete old data because the old data is different data type. Then data type changes, always remember you can't do data type changes on existing data. Definitely the table should have a empty, or you have to override. Override, what will happen? It will delete old data. But remember, applying override, it will impact losing your old data. Take a backup, then do the override, and reload it again. That's all. Take a backup, reload it again. So create another table, take a backup, then reload it again. So override schema works with the override option, not with append. Now that's why we won't prefer this, because you'll be losing your old data. So this is about schema enforcement and schema evolution. Schema enforcement means by default it will validate the schema, it will reject. Schema evolution means adding a new columns with a merge schema, but not with override schema. Override schema, again you need to use override. Then override will be losing your old data. But without impacting on old data, just go and use merge schema. Your old data will be there. Your new columns will come with the new data. There's no impact on the old columns and the old data. That's why override schema we won't prefer, but still you have an option. Override schema and the override option. It will delete all data. It will change the data type. So schema evolution only for adding a new columns. It's called merge schema. By default, schema enforcement will be there. Enforcement means it will validate each column and each data type. If it is not matching, it won't insert into a target table. It will reject that. So this is about delta features. So tomorrow what we'll do, we'll understand other features. Time travel, restore, which we already done. So timestamp as of, version as of. You can use a version number, restore also. So I'll share this notebook, and tomorrow what we'll do, we'll understand the merge. Merge also important, which we can use. Another one is vacuum. Sorry, a vacuum and cloning. So merge in how to use a merge, how to do the incremental in SQL or PySpark, both. The cloning, actually Delta supports two types of cloning, but Fabric supports only one type of cloning. That we'll see that tomorrow, okay? Delta supports two types of cloning, but Fabric supports only one type of cloning, okay? So cloning, the merge, we'll see that tomorrow. Any questions?